Hello everyone, my name is Timothy Lee Grant, and one of the things that I am trying to do here on my YouTube channel is investigate how we are able to use a lot of these AI tools which are now starting to come online. How do we use those effectively? How do we not just vibe code, not just like build from zero and just input into the text, like build this application, I want it to be like this, I want it to be like that. What I actually want to do, the ultimate goal, is to be able to take those skills which we are learning within the vibe coding series and be able to use it effectively as bolstering our capabilities as a software engineer. So, how do we actually increase our productivity? That's the main question that I really want to understand. And I am going to be practicing that in this video. So there's this library, it's called PyGPIO, and I have my little Raspberry Pi right here. I'm planning on doing a project with this in the future. I'm trying to figure out how do I actually access the IO pins on the Pi? How do I have this interaction with this hardware device? And there is a library, you can see it right there, PyGPIO, and there's a GitHub right here. And there's multiple different components that I'm trying to understand how they fit together. There's a daemon. There is this Python library, I think it is, that I know that I'm able to have a Python script and I'm able to do like import and then PyGPIO and then do function calls on that library. But then I also need to start a daemon, which is also in this GitHub. And then there are a bunch of C files within this GitHub. So what I want to do is I'm going to go in, I'm going to clone this repository down to my local computer, and then I'm going to start investigating it. But normally, the way that I would be doing this is just with my own eyes. I'd be looking at it, I'd be trying to understand how everything is fitting together, I'd be trying to make the connections. Today, we are going to do something very different. We are going to have AI look at it, have AI investigate it, and see how it does melding all of these things together. And in particular, I want to know, how do these different components, how are the daemon, what part is the daemon? What part is the Python library? How do I call this if I'm not in Python? How do I call it from a different language? And so I'm trying to investigate, how does AI synthesize knowledge and be able to present it to me in a useful format such that I can supercharge my speed as an engineer. So that's what we're going to be doing in today's video. Let me make myself a little bit smaller. There we go. Okay, so here's the GitHub right here. Okay. Now let's go and get the code. Okay, so we can get it here and then terminal, new terminal, and then close this out. So git clone and then there. Okay, so we will be going in. Looks like it got it already. Okay, so now from the model, I want to say investigate the PyGPIO code in the folder. Okay, I want to understand what is inside of it. Generate an output file detailing how the different components in the project work together. I also want to know so I'm trying to figure out how is the daemon working, and what is the relationship. I can kind of go in here and show you what I'm talking about. So we have all of these different C files here. Like we have this pygpio.c here, and there's just a whole bunch of stuff, right? Like my path bad. I'm not sure what that is. Timestamps. Um, but it seems like this is talking to the hardware, which makes me think that these C files are part of the daemon. And then I know that I need to take this library, or not this library, but I know that I need to like make install it and then take that and put it in as a daemon. But I don't know why I'm doing that, and I don't know exactly what I'm putting as a daemon. So I'm trying to figure out, okay, well, how do I do that? How is this interacting with the hardware of the Raspberry Pi? How then we have other files which are .py right here. So now this is kind of like it talks about being like a wrapper. So here, which talks to the Pi GPIO daemon to allow control of the GPIO. Okay, talks to the daemon, but what part is the daemon? How does it talk to the daemon? I'm trying to figure out where all of those connections are and trying to trace through, like, okay, well, there's this big repository, there's a ton of files, there's a ton of code, there's a ton of lines of code. What is the connection? How is data flowing? And if I want to write a program within a different language, let's say whatever language it is, let's say it's not Python, how would I be able to access this daemon? And who am I talking to? Am I talking to the C? Am I talking to whatever it is, right? I also want to know, I will say, it seems as if there is a DAEMON. There we go. Which might be part of this project. I want to understand which part is the DAEMON, is the daemon. Okay, how does information flow between the code that I write when I do a import PyGPIO within my separate Python project? Okay. Like this. And I don't know if I'm asking it quite correctly, so I'm going to keep thinking about this. Also, does it have access to everything, or... So I wanted to have access to all of this, right? I guess we'll see. We'll see if it has access to it. Hopefully it does. Okay. So now that I did that, I am trying to get an understanding such that I might be able to write functions within C# to be able to communicate with the daemon myself. But I don't really know who I'm talking to, who or what I am talking to. Investigate the code, do diagrams, and explain everything in the output file. Okay, let's just see if it works. So optimizing for tool selection. While it's doing that, I'm going to take a sip of coffee. Okay. So it looks like it is getting, okay, so it is getting the all of them. Okay. Awesome. So yeah, it's looking, it does have access to all of these guys. So I'll just let it do its thing, and then we will be able to investigate um, the markdown file which it creates for us. And then possibly if we don't like what it did or it's not quite right or something, we might need to go in and prompt it a little bit better. So, but this is just first round, see what it comes up with, see if it's usable, and then from that, try to understand uh, the general picture. And also, we need to not only just understand this specific problem, but kind of the meta analysis of how did AI do? How was our process with AI? Was it effective? Is there ways that we can make it better? How do we supercharge our abilities as engineers? So, those are some questions that we're trying to look out for in this video, and once it gets done, we will be able to investigate that. Okay, so perfect. I have enough context. Let me create a comprehensive analysis. I'll create a markdown file explaining the architecture. Great. So yeah, I see the make file right there, and I think this is what does the daemon. I think. Um, but then we have some like a .3 file. Like what is a .3? And then I saw other dot numbers. Was there a .6 somewhere? Oh, wait, whoa, 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 it's going, it's going, it's going. Okay. So 1,300 lines. Nice. Is this what it created? Okay, here we go. Okay. Let's investigate this and see what it's saying. Okay. So, first off, I'm curious, like, how large is it? Okay, okay, okay. So there's definitely a lot of content, and I see that it's putting it into separate parts. Okay. Nice, nice, nice. Okay, so first observation is it definitely was it's definitely in detail. Let's kind of see the quality of this. So, uh, pig, uh, Pi GPIO is a sophisticated GPIO control library for Raspberry Pi that uses daemon-based client-server architecture. Okay. This document explains how the components work together, how information flows through the system, okay, components work together, that's what I want, how information flows through the system, yes, and how you can build C# clients to communicate directly with the daemon. Okay, that's kind of what I'm looking for. So far, it seems that this is on the right track. Okay. Part 1, high-level architecture overview. System architecture diagram. Raspberry Pi hardware. Okay, so, and this is another thing that I didn't explicitly mention in the prompt. I said it. I actually said it when we were talking. I was talking about how does it communicate with the hardware? And I want to know, like, from the hardware all the way up. But I didn't say that in the prompt, but it got it here. So it's going in that direction, which I like. So the Raspberry Pi hardware, we have the GPIO pins, we have the pulse width modulation, we have all of these different controllers, peripheral devices, etc. So this is all of the stuff that you actually have access to on. Let me open this up for a second. So see the IO pins like right. The lighting is not very good. There we go. It's almost there. We go. All of those right there, the IO pins. So we have all of those IO pins and some of the peripheral devices, which we are able to communicate with or control, I should say, from the Raspberry Pi. So the Raspberry Pi is able to either take those pins, make them an input or an output, and then if they're an output, you can set them high or set them low. If they're an input, you can read them high or read them low. Obviously, PWM, you're going to be able to create from those PWM pins, you're able to create a signal based off of it. So, all right. So from here, we go down to this direct C library and Pi daemon. Okay, so these two things seem to be separate. Okay. And here's the Python module. Okay, here's the Python library. All right, so direct C library, lib pi, get this here. Let's look for this. It's one of these here, right? Are we seeing it? libpi.so. I am not necessarily seeing this. I know SO is what is that? That's a Linux DLL essentially. Which, by the way, actually kind of is cool because in the last video, one of my engineering investigation videos, we were just trying to find random concepts that we didn't really understand, and we happened upon DLLs, and we saw SO, and so we're able to make these connections, which is why I'm a huge proponent of just trying to understand all of these different concepts because you never know where you're going to make a connection with. So because of that, I now here am able to look at this. I see .so and realize, wait, hold on, I know what that is. That is like a compiled Linux DLL that I'm able to utilize. So from here, we get the memory mapped I/O access. Okay, DMA PWM timers hardware control. Okay. Now there's something else, which is the Pi GPIO daemon right there. The D stands for daemon server process. Okay, and this is socket server, command parser, notification manager, and this uses TCP on port 8888. Okay. So I guess this is how I communicate with the daemon. I'm not sure. Just looking at the architecture of what it created, and then we have these C applications direct. So from what I'm getting, a lot of maybe these C applications like pigs.c and pygpio.d.c, maybe these interact with the daemon and are not the daemon themselves. Not sure yet. So Python module here. This is the pygpio.py. We definitely seen that one. That one is right there. Okay, it's this one, and it interacts with these two as well. One thing I am noticing, we have these arrows here. So the hardware, there's a two-way connection between hardware and this library. Okay, same thing with the daemon. Now, this one seems to indicate that nothing can come up and directly interface with the socket itself. Okay. Is that true? Okay. So the three interfaces. PyGPIO provides three distinct interfaces to control GPIO. The first interface, direct C library interface. So this is that lib pygpio.so. Direct function calls from C programs. Okay. Lowest latency requires root privileges. Same process as GPIO control code. Okay. Trying to understand what exactly this is meaning. So, direct function calls from C programs. So we're inside of C, that's what it's indicating. And okay, so inside of my C program, I can do include pygpio.h, and now from what I'm seeing, this gives me access to direct function calls within my C program. Okay. One interesting point of note is when it says requires root privileges, does that mean that I need to execute the file as like sudo and then execute the file? Maybe. I'm not sure. Okay, so, or the executable, I mean. So, we have this main, initialize the library. So these here, I'm guessing are going to, let's look at pygpio.c. This just says GPIO. Okay. So here's pygpio.c. Now, okay, actually here's the H file, so it's a little bit more condensed. Not really condensed, but we are going to be looking for, I'm just going to make sure that this is not a method, but this function, okay, is in here. Okay. So here it is declared, so actually it might have been better to put it in here. So here it is, and here's its implementation, right? So as of right now, I'm not too interested in like how exactly it's being implemented. I just want to say like it's in here. So from my C, I include the H, and it gets this directly here. Okay. And now this, I think, is interacting direct function calls from C. Memory mapped access to hardware registers. So what it seems like is this C might not be communicating with the daemon. I don't know if that is accurate. I'm just thinking out loud right now, because what it appears to be is that this this library, or this .h library, these two files together, I just import both of them from and within my C program, and then this library has memory mapped access to the hardware registers within the Raspberry Pi, and I don't need to mess with the daemon. I just access the hardware directly. Okay. Maybe. I'm not saying a definite yes. I'm just saying from what I'm reading right now, this is kind of what I'm thinking is going on. Okay, so socket interface. This is PyGPIO-D daemon. So client server architecture, commands sent over TCP sockets, can work over network, default port 888. Multiple clients can connect simultaneously, okay? Then pipe interfaces. Okay, so another thing, we keep going back to our engineering investigation series. I do all of those videos where I try to almost every day create a video which is an engineering investigation video. And in those, I just go and I take notes of every single time I enter a or I encounter a concept in engineering that I'm either have never heard of, that I don't quite know or understand fully, and that I want to investigate a little bit further. So I just create a note, and then I come back home, and then we do these YouTube videos where I just go and investigate them. And one of the things that we were investigating is kind of this right here, which is like kernel modules within Linux. And so you are able to create your own driver for a kernel module that has all of those high level privileges to be able to do kernel operations. And the way that you access that kernel driver is through a file in your file system on Linux. And I believe it was very similar to this. I don't have that memorized, but I think it's this. So this makes me think in that direction, that it is a file right here, or a kernel driver, something to do with kernel drivers. So first in, first out based communication. So, okay. Local machine only, text or binary protocol. Okay, so for your C# program, you'll use the socket interface, number 2. So this is kind of what we are interested in, okay? So I want to know more about that. Okay. So the daemon GPIOD, the core server. So what is this? It is a standalone daemon process. Okay, that runs as root in the Raspberry Pi. Okay. So now it's going to tell me what this daemon actually is. Okay. So it runs as the root on my Raspberry Pi. It runs on root. It listens for commands on a TCP socket, port 8. Okay? So I'm thinking if I run the daemon, I should be able to send data or commands or something to localhost 8888, and from that I should be able to control the pins on this Raspberry Pi. That's what I'm thinking. Sends notifications back to the client when GPIO states change. Okay. So starting the daemon, we need to do sudo and then run this. Okay. And then we can also have it listen to a custom port. I don't care about that. It can be on 8888. With custom network, localhost is fine for me. Foreground, useful for debugging. Okay, so the daemon architecture internal. So let's see how this is working. Pi GPIOD process. So socket listener thread accepts TCP connections. Okay, listens on port AAA, creates handler threads per client. Okay, so it's just talking about how it is able to listen and creates a new thread for each client that tries to connect to it. That's fine. That's whatever. Command handler thread, 1 per client, receives commands from client. Okay, so I am kind of in the right direction, that it is commands that the client sends. The client sends commands to this daemon, okay? Parses command format, execute GPIO operations, and then sends the result back, okay? So now this GPIO core library, direct hardware register access. So DMA, PWM, timing, interrupt handlers, okay, state management, okay, hardware drivers, GPIO pin control, clock, timer, peripheral, I2C. So this is hardware drivers, notification generation, okay? And then all of this goes to the Raspberry Pi. So first off, we send a command. That command gets processed. It goes to this core library. The core library has specific hardware drivers, and let's just say that we want to set pin 1 to be high. And then this driver interacts with the hardware. So that's kind of how this process works. Okay, awesome. Key source files for the daemon. Let me take a sip of coffee before I continue. Okay. All right. So key source files for the daemon. So this is one of the questions that I had about where is it? Like, I see a whole bunch of files. I see .h file. Okay. Whenever you're gonna have uh, a C project, you're gonna have .h and .c files. But I'm also seeing that .py. I'm seeing uh, just a lot of different files. I'm trying to figure out what's the daemon, what's the C, like what's this one, right? The C applications, what's the Python application, how is all of this interacting? So key source files for the daemon. Let's look this up. So we have pygpiod.c. Okay, and we have seen that one before. I almost misclicked on it. I was trying to click on this one, but I almost clicked on this one, which is what we're talking about here. Okay, so this one here is going to be main daemon process, initialization, socket setup, thread management. So this is dealing with, all of these are dealing with kind of setting all of this stuff up here, right? pygpio.c, core GPIO library. Okay. So command.c, command parser. Okay, so that, I did not get that. See, this actually would have taken me a very long time to go in and understand, like, how is command.c. I hadn't even like looked at this file. How is command.c interacting with everything, and is it part like, what's its actual organization in this big thing? Okay, so if I'm trying to, what if I'm trying to let's see, bit banged I2C open? Like, what if I'm trying to perform this command here, and like, what is the actual command? I see pi command and then b I2C and then 0. Is this like a enum, or is it like, where is this defined? How do, I'm just thinking of different like things right now. Like, okay, awesome, we have these commands. How do I actually utilize this? Okay. And then definitions, command IDs, structs, protocols. Okay, yep, awesome. Um, okay, so pygpio.h, public API header, all function declarations. This is another one that's okay, so public API header. Is that what I'm looking for when I'm trying to actually call an API? So essentially, when I'm trying to do a command, how do I do a command? That's kind of what we're trying to figure out. Okay, so maybe we need to go back up to that again later. We might need to reference that a little bit, but let's come down here and keep looking at things. Okay, so communication and protocol. I'm curious, like, so I put my marker here. We are not even like 1/10 of the way down. So this thing definitely made a very large very large output file, which is good in one sense that it has a lot of information, and condense, like, maybe we need to experiment, like, how large do we actually want it to be able to feasibly go through something really quickly, because if we just get bogged down in this, right, like that slows us down as well. I want to supercharge things, but at least for this video, I do want to go through it and just see what it output, and that way we can know better for the future, like, okay, well, how do we tweak these things to supercharge our development process? So, okay, the socket interface uses a binary protocol with fixed size commands. Okay, optional. Okay, this is the communication, how client talks to the daemon. So we're trying to figure out how we actually interact with this daemon. I think that this is meaning those calls. I'm not sure. It doesn't explicitly say. Okay, so fixed size command packets. So all commands, from what I'm reading, are going to be 16 bytes. Okay. Optional extension data for some commands. Simple request. Okay. Awesome. So offset bytes field type. Okay. Total is 16 bytes. Okay. Where command equals command ID. See command list below. Where's command list? Would it be here? Maybe here? Command reference. Okay. So is it talking about this ID right there? Okay. So command ID. Okay, command right there. And then P1, P2, parameters 1, parameters 2, meaning depends on the command. P3 and result. So is that what's given back to us? So we have 3 bytes for the command? That seems pretty large, don't you think? Like, I at least what I'm used to is 16 bits. So we have two bytes, and each one, right, you can like send it over I2C and get your result back. And so that's what I'm used to, is like 2 bytes, but this is 16 bytes. That seems like enormous. Okay, so set GPIO output. Let me take a sip of more coffee. Okay, so set GPIO 4 to high. Okay, so this is going to give me an example. Awesome. So what are we trying to do? We want to set a pen number 4 to high. We want to set it to 1. Okay. So command, write GPIO, we're looking right here. Write GPIO command equals 4 equals pi command write. Okay. So let's kind of look down here. Do we see, what is number 4? So 4 is write GPIO level, write GPIO level. Okay. Sure. Okay. Okay, parameter 1, P1 GPIO number equals 4. Parameter 2 is high. Okay. Okay, so we're right here. Do we see P1, P2? So number 4, we have right. So command, and then P1 is going, this, I wish that this was kind of aligned. Okay, let me, this is command ID, number 4, that makes sense. Right is the name, okay, that corresponds to the command. Then the GPIO that we want to set is also 4, because we're looking at pen number 4, okay, which is different than the command. The command's ID is 4, but we're trying to write to pen 4, okay, so this is going to be 4 as well. And then level is going to be 1 for high, and then purpose is write GPIO level. Okay, so what we want to do is write, so the command is going to be equal to 4, the P1 is going to be equal to 4, and P2 is going to be equal to 1. Good, we got it. Okay, so now what are the actual bytes which we are going to be sending? Now again, this seems like overkill to have such large data packets being sent, because like look at this. So we have one, like, so this is like one, this is just to say command 4, and look how many zeros we're sending, right? Like, there's a lot of information which is not really being used at all. And when you set this to be the actual bit, because these are like hexadecimal right there, if you set this to be the actual bit representation, like this one right here, you would have 7 zeros and 1 1. Okay, so it's actually, if you take both of these into themselves, it's like you're only using 1. And so, I don't know, it just seems like it's a little bit, there's a lot of unused information which is being sent. But anyways, we're not doing an analysis of that. We don't care about that. We're just trying to understand how to use it. Okay. Raw bytes. Anyways, let's so we want to do the command first. Okay, so 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. All right, so all 4 of them are going to be the same length. Okay. First one is we just send 4. We just send 4 again. We send 1. So that's how it kind of goes. Okay. Awesome. So now to read GPIO 4. Now we want to read GPIO 4. Before I actually go and do that, let me look. What do I think it's going to be? I want to do 3. So the command is going to be 3. And name is read, yeah. I want to read 4. So command is going to be 3. P1 is going to be 4. And P2 is going to be nothing. Okay. And then how does it send the information back to me? Okay. So now, okay, so we just set it to be 0. So 3 and 4 and 0. Awesome. And then we get we set this one to 0 as well. Okay, so then we get a response back from the daemon, 0 0 0, and then the appropriate response. Okay. All right, so that's how we send the data to the daemon. It didn't specifically say how we do, like, the protocol as well. Like, do I just do, what would it be, like a curl command to localhost a port 8888 and then send it as a, like, how do you actually send that command? Okay, so Python example. Here's the Python module. Here's how the Python module sends commands. Okay. Here. Um, so pygpio command, uh, socket lock command p1 p2. Okay, so now I'm starting to see what this p1 and p2 is. Okay, so command packet was struct here, command p1 p2 now sends to the daemon. So dot send this command packet 1 2 3 4, maybe that's 4, I don't know, but we send the command which is going to be equal to 4. Okay, so this is a passed in parameter, this is a passed in parameter, and this is a passed in parameter, and then this is that response, but we always set it to 0, I think. And then we receive it, so we can do just this receive, and we're receiving 16 bytes, okay? And then from that we get back command p1 p2 result, just like we saw up here. Command p1 p2 result. So then we can capture that and just return the result. Awesome. And socket object is going to be here. Okay. And then, yeah, these are just defines. Yep, that makes sense to me. So the daemon supports over 118 commands. Here are the most important ones. So I might actually even want to go in the code and look at these myself so that I can know what are all of the 118 commands that I have access to. And it's still, so far, we have not really gotten to the point where we haven't gotten to the point where I actually know how to send commands from my C sharp. And I'm just saying C sharp because what if we wanted to do C++, right? Like, I want something other than C, and I want something other than Python. And let's just, right. Anyways. Notifications. Notifications are sent from the daemon to the client. From the daemon to the client asynchronously when GPIO states change. Okay. Notification is 12 bytes. Okay. Hold on. Is this? No. Okay. Okay. Flag. So watchdog timeout, alive indicator, flag indicator. Okay. So data flow, how Python GPIO modules work. My Python code. Okay, so I know how to do this from Python. Okay. Now, what I normally do is just import pygpio, and then from that I'm able to, and it shows it right here, instantiate an object called py just from here, and then do py.write. So I access methods within that py object, and I'm able to control the IO from that object. So I'm trying to figure out, okay, I know that I can do it, right? And I know how to do it, but I don't know actually what is going on when I do that. And I don't know where in this, how that data actually interacts. Okay, so Python module converts high level calls to command. Okay, so when I do this in my program, so this is my program, and I import this, it gets sent to the module, okay, converts pi.write to command structure command 4 because this write is a method within the object, and we know if we're trying to write, that means it's equivalent to 4. Okay, and then we're trying to write to pin 4, and we're trying to set it high, so it knows to fill out those parameters. Awesome. Packets as binary, sends via TCP socket. So the Python module, does things via sockets as well. Okay. So it automatically, wherever it was .py right here, it will do a binary packet over TCP. So host, port, and then, yeah. Then TCP socket connection network communication layer. Packet arrives at daemon. Okay. So now socket listener receives 16-byte command packet. Okay. It receives that command packet. Handler thread unpacks. Handler thread. Yep. Gets command 4, gets P1, gets P2. Awesome. Awesome. This is sent to command.c, which we saw here, right? And this is what kind of grabs those commands. Let me highlight this so we don't lose our spot. But up here, where'd it go? Here we have that command handler. So we just sent it to the thread, or to the TCP connection, right? It grabbed it from the connection. The daemon grabbed it from the connection. Now the daemon is trying to parse it and say, okay, well, which file or which command actually was being sent to me? That's done in command.c. Okay. Here. Okay, so command.c parses file and verifies that the parameters are accurate or valid. And then pygpio.c executes it. So this one here actually will go in and perform those hardware accesses with the registers, okay? And then hardware operation, Raspberry Pi hardware. So GPIO register writes. So, okay, there's two things going on right now. First one is I'm trying to understand how C# or how this project is set up, right? I'm actually not too concerned about how this PyGPIO actually talks to the hardware. But on the other hand, I'm kind of curious, right? Like, I'm curious about how does the interaction between just setting certain values at register addresses, how does that, right? Like, it's kind of something you don't normally do too much. Or if you're doing stuff in like embedded, you can just use like a SDK, which is just a library for that given like part, whichever microcontroller you're using, and then you just do the function calls on that microcontroller, or on the SDK library for that particular microcontroller, and it handles all of the register communications. So it's a very interesting thing right here. I'm balancing these two things. I'm like, do I want to look into that? Do I not want to look into that? But for right now, in this video, we are focused on trying to use AI to be able to understand the code base here, this large code base, and understand and supercharge our process. So I'm not going to get bogged down in the weeds right now, but it might be something interesting to look at in future videos. So this uh, this pi GPIO does magic and sets whatever needs to be set. Okay. Now the daemon response. So returns status results value back over the TCP, and it goes back to that module, receives the response, unpacks the result, returns it to the caller, and then I get my nice happy little return. Okay. So now Python module structure. I'm going to take another sip. Okay, so pi gpio.py initialization. Okay. How much of this do I care about? I don't think I care too much about it, honestly. Command settings. I'm not too worried about the Python actually. So building C# client. This is what I'm a little bit more focused on, right? Now that you understand the protocol, which we do, so I just want to take a little time out right now and say that was extremely helpful. That cleared up so much misunderstandings that I have about this code base. That saved me. This right here, what we've read so far, has saved me so much time and energy. And I understand it much better now. And instead of using AI to do the job, right? Like now I'm using AI to booster myself so that now I can just start developing. Now I understand what's going on and I'm able to use the code base, which I would have had to study for hours and hours and hours and hours. Now I already understand what is happening here, and I'm just thinking out loud right now. Does this negatively impact my learning? Um, I don't know how it would or would not. Obviously, if you're struggling with something, that's not a bad thing, and you learn a lot while you're struggling. But there's a specific type of struggling which is good, and other times when you're doing it, you're just spinning your wheels and not getting anything. And when I'm trying to find the connections between things, I actually don't know how effective that is in building comprehension. If I get the roadmap and then I understand each component and I struggle to understand each component, right? That's actually very effective. But just being blind and kind of not knowing where you are at all, that I actually don't know that that's a very effective way of learning. So actually this might make learning more efficient. And I not only am able to, number one, complete my projects and my development as an engineer quicker, but number two, it can help me focus on learning effectively because now I'm not confused about an example is if you are doing calculus, right? You're trying to learn calculus. Do you want to get bogged down because you are just because the teacher is talking about every single concept within the realm of calculus, and so you don't know, okay, here he's talking, one day he's talking about limits, the other day he's talking about Laplacian transforms, the other time he's talking about um, whatever it is, I don't know, vector fields, right? Like every single day and you don't know how these fit together. No, it's actually much more efficient to have a structured approach to say, okay, we are going to start off here and you are going to learn this. First you learn limits. Then you learn what is it, L'Hopital's rule, right? That was Calc 2 or integral calculus, the beginning of integral calculus. Then you learn integrals. Then you learn more advanced integrals, right? So it's very structured in how it is taught, which is why math is so effective. Why the math programs are so effective, because they structure how things are learned, and it's not just you go and randomly learn things. So I'm seeing a very good use case for AI is to be able to structure things in a way that you are able to systematically learn and just fly through it. How long would it take you if I gave you all of these different random topics within calculus? How long would it take you to learn calculus? I don't even know if you would be able to, because you would be struggling so much to even understand how all of these things different fit together. Which one should you start with first? You might happen upon, as I said, like vector fields, right? And you're trying to do a line integral through a vector field, and you're just like, you have no idea what an integral is, you have no idea what a vector is, you have no idea what a derivative is, because you don't know where the starting point is. Okay, if you're structured, you just sweep right through it. Okay. Anyways, uh, so C sharp architecture patterns. So with this, we are now trying to architecture pattern. What is that? Your C sharp application, GPIO client, class you write. Okay, so I write this uh, in my program or in my project. Okay. Darn, I should have been more conservative with my coffee because I'm out now. Um, I always have two things, but I'm out of both. So darn. Anyways, so TCP client connect. So I write this. Okay, command send method. So I do this set mode write read. So I have to create my own things here to be able to do a TCP client connection. Okay. Command structure. Okay. Notification receiver. Listen for notifications. Okay, so this is the structure of my C sharp application. And obviously I'm going to have other stuff in there, but this is just like how I can interact with this daemon, right? Okay. Okay. Basic C sharp implementation template. So now we are coming here and we're going to see, now it's going to start talking about how to actually implement this in C sharp. Okay. So, all right, that's just the import statements. So command IDs. So we want 4. That's kind of like my anchor point now, right? Because it went through this write 4. And so now when I see 4, I just try to verify, like, is my understanding correct? And yes, it is. Look, so command write equals 4. Okay, awesome. And then we have the other commands, which whatever they are. There's a whole, I think, 118 of them, it said. Awesome. So now, GPIO modes. Public const input output. Okay, fine. Command structure. So struct layout kind sequential pack equals 1. Okay. Private struct command pack. Okay. So unsigned integer command. So all of these. Okay, so here are our fields within the command packet. Okay, that makes sense. Yeah. All of them are going to be unsigned integers. Okay, that makes sense as well. So TCP client, did we auto Is it within this sockets? That would be my guess, is it would be within the socket. So we're creating a private member variable called client and stream. Okay. Is this within a class here? Yes, it is. Okay, awesome. Awesome. I just want to make sure that my... Okay. So now we have methods called PyGPIO client, and we're setting it to localhost and 8888. Yep, okay. We're setting client equal to a new TCP. So we're calling the constructor on for TCP client, and we're passing in host and port number, and that's going to return us a client, and then we just do get stream. Okay, so that's more taken care of, I'm guessing, in this library, probably. All right, so after we get that, send command. So this is another method that returns an unsigned int. And why is it an unsigned int? That's because of up here, like, the response is an unsigned int. Okay. So, okay. Normally, this actually brings up kind of an interesting point. Like, normally I don't think about how many bytes is an int. How many bytes is an unsigned int? How many, right? Like, now it's actually kind of important, because we're normally, if I'm interfacing with a register that I need to write 8 bits, okay, what I do is uint 8. Like, I specify you are 8 bits, and then I set the bits exactly equal to what I want, so whatever it is. So uint 8 var1 equals, and then 0x for hexadecimal, and then A1, right? And so I just set it like that. So I say you're 8 bits. I define it as an 8-bit variable, and then I set those 8 bits, or I manipulate them later on in the code, whatever it is. But now this one is like, now we're starting to talk from the higher levels, not the really embedded C, or C sharp, which is a higher level language, but we're interacting with the low level. So now there actually is kind of importance of, well, how big are these variables? Okay, so anyways, it's just something noticing, trying to understand and figure out what's important. What are some of the things that I need to just keep in mind? Okay. Anyways, so this is a method within the class. Okay, so send command, we have the command p1, p2, just as we saw in the Python. Awesome. So we create a packet, create packet, which should be here. Yep. Wait, hold on, no. A command packet, not create packet. Yes, so we're just creating a struct. And we're setting that struct equal to those fields. Awesome, awesome. So now convert to bytes, little Indian, okay? So now let's see how we take this packet and actually send this, how do we send it? Okay. Oh my goodness, this is amazing. I just, again, I want to pause. Like, the way that this AI model, that Copilot, was able to take in this huge, no, it's not huge, but yep. Okay. It's not this library, or this repo, it was able to synthesize everything. It was able to put it in a format that I was able to quickly understand. Unfortunately, when I'm doing these videos, I don't have any indication of how long I've been filming, so I don't know if this is 30 minutes right now. I don't know if it's 50 minutes. I have no idea. The only time I have is that little like the clock up there, like 5:01, but I don't know when I started. Um, so however long this video has been so far, um, I've been able to have a very good understanding of now how all of these different components fit together, how they interact, and how I, as an engineer, need to move forward to be able to accomplish what I'm trying to do. And here, now it's giving me the exact roadmap of how to do it. Very good. Very good. Very good. Very impressed. Okay, let's just keep looking at this. So we're creating a byte array called data. Awesome. And we're saying it is going to be 16 bytes. There we go. So this is what we're going to be sending, isn't it? So, okay. Buffer, which is declared where? Is that like a, maybe it's a built-in C# thing. I don't really know. But buffer block copy. Okay, so there's a method called block copy, and I'm guessing it takes parameter. I might need to look into that one a little bit more and figure out what exactly is happening, but we're let's see, bit converter. Okay, get bytes. So we're taking the bytes of this command here. Okay. 0 data 04. Okay. P1, P2, P3. So the command and then the arguments. And are we pasting, or are we like putting it into data here? Because right now data is uninitialized. So I'm thinking we are putting it into data, but I'm not sure. Because then I see that we send data. Okay, so we send it over the stream. So that's that TCP connection. That's how we make the TCP connection. That's how we send it. Okay. Very good. That's how you do it. Awesome. So now what I can do is I do byte response. Is awesome. That makes complete sense to me now. Now that I've read through everything, I look at this line of code and it is just obvious. It is, how could it be anything else? Would this be 13? Well, of course not. Why? Because the response is not going to be 13 bytes. How could it be anything else than a byte array which is of size 16 bytes? It is crystal clear obvious. Okay. Stream, and then we read 16 bytes. Awesome. So bit converter, then we return back in bits, right? To unsigned integer 32, the response. Okay, and then I'm guessing this might be the padding, right? Okay, so now set mode, and then we have write. So what is send command is up here, and now we're just awesome. So now here's how we implement those different commands. So what we do is we just set this defined parameter, and then the different arguments which we are going to be sending here. So command P1, P2, command P1, P2, right? Like command P1, P2. And then if we want to close, we just close the stream and close the client. Awesome, awesome, awesome. Okay, so now let's keep on going. Public class program. Public stat or I don't know why I'm reading that. Okay, so this is our program and this is just the main entry point. So using var pi equals this pi GPIO client. So this is how we instantiate it. That's the object, right? Yes! We got it. Okay, yep, that makes sense. Awesome. And then I can do the set mode for, yep, awesome. Yeah, yes, makes sense to me. So now C# advanced features. Async notification listener. All right, so this is also kind of interesting. Like, how do we do asynchronous situations where the hardware might send us something? The hardware. What if I'm on my Raspberry Pi? I have an pin which is an input, so I'm trying to get data from it, and I want to know when this input pin transitions from a high to a low, or a low to a high. So what's going to happen is the input pin is going to transition. Then the hardware is going to notice that. It's going to send it to the daemon. Then the daemon is going to have to send it up to my C#. How do I do that and get that message asynchronously? Okay, so let's take a look. So private async void. So we just declared the function as async. Listen for notifications. Awesome. So we create a byte array of 12. Okay. Now the number 12 came up. I'm highlighting that. And I remember seeing it, and I kind of glossed over it a little bit right there. Okay, so this is notification system. So this is the asynchronous, right there, asynchronous notification system. And we have sequence, flags, tick, and level, okay? And now notice this is 8 bits. Not bytes, bits. Wait, but at 12 bytes up here. Oh, flag bits. Here. Bytes 2 and 3. Okay. Here we go. That makes sense. Okay. Okay, so that's where we saw 12. So let's come back down here. Creating this notification buffer while client.connected. So this is, we're doing an infinite loop here. And one of the questions that I'm going to have is, I know that, like, this is something that I need to investigate about how C# does asynchronous functions, because I'm not quite sure. When it's waiting here, I believe it will yield to all of the other programs, or like threads, or like, how do I use this? And I want to be doing other stuff on the side, right? And then I would just want to be notified when something occurs and then come right back up here. And I think that's what happens, but I don't know how to actually instantiate everything and make sure that everything is working. That's something that I, as a developer, or maybe I can ask follow-up questions with AI. I can take this and put it into a different model and investigate it. But as an engineer, now I'm thinking about implementations. I'm trying to say, okay, well, I'm not exactly sure how I'm going to do it. As an engineer, that's one of the things that I need to figure out is, okay, make sure that I set up my project in such a way that I am able to utilize it. Okay. Parse the notifications. So unsigned short sequence. So I'm getting from the notification buffer and setting it to sequence. That should be the first 0248. Okay. Sequence flags tick level. I'm guessing that that aligns with what we saw up here. Sequence flags tick level. So 248. Okay. That's like maybe like the stop, the last, or the first. Yeah, the first one. Okay. And we take 16. We take 16, 32, and 32, maybe. Okay. And then we just do a console write. So we print this to the screen. And then I think we just come right back up here and await for something else to occur. Okay. So complete information diagram flow. So my application, any language with socket support, create connection with local host. I can do read writes. I send this data there. And then the daemon comes here, receives and parse commands, read 16-byte packets. Awesome. We kind of understand this already. Hardware access. PyGPIO. Yep. Okay. Sends it back and continues execution. Awesome. So now what I can do is notification flow GPIO state changed by external device. Okay, so this is when the external world has changed around, and how does that information flow to me? Kind of what we were just doing, right? So interrupt handlers detects GPIO change. So whenever an interrupt occurs or the outside world changes and we need to be notified of it. So sends notification to all connected devices. So we have a TCP connection and it's going to broadcast that. Okay, so 12-byte notification packet, sequence flags, GPIO tick, GPIO level, right? So we have that. Each connected client receives notifications asynchronously. So as of right now, I just have, and it says it right here, I just have one, so I'm not caring about all of this. But if I had multiple applications, it would be broadcast to all of them. All notified simultaneously or handled by app threading. Yep, makes sense. Okay, detailed component reference. Pi GPIO D daemon. I just noticed we are like only halfway. Oh my goodness. Okay. So part 7, detailed component reference. So parse command line arguments, initialize GPIO library, create socket listener, spawn thread per client. How much of this do I actually care about? Now, what I mean by when I say care about is obviously as I am trying to improve myself as an engineer, I can gain knowledge from everywhere. So I care about it because I want to learn more. But if my purpose is to be synthesizing data such that I can move forward really quickly and advance, I actually don't know if I care about this. Like it might be something that I can not focus on right now. Um, so key functions. Main fatal direct hardware register manipulation, GPIO mode level control, PWM generation via hardware, I2C, SPI, UART, so the communication drivers. Waveform generators. So I do care and I don't care. As I mentioned when I was talking about, let me mark that so I don't lose my place. I said, where is it? Here, somewhere. Where'd it go? I said that I don't really. It was one of those graphs. Wasn't there? So I said that I don't really. I can't find it. Anyways, it was when I said I don't really, for the purpose of what I'm attempting to do right now, I don't want to get bogged down in the weeds. And I was saying it's very interesting how you're able to write to a register to control the physical hardware on the device. But that's not kind of what we're looking at right now. And so this is kind of in that realm, which is how do you actually control these hardware devices on the physical Raspberry Pi. Um, so it's not something that I need to look at immediately. So the different data structures. So that's why I'm going to kind of gloss over this pretty quickly. Command.c. This might be of interest to me because I want to know all of the commands which are available to me. Command right here, GPIO right. Why is this not 4? Command 4. Oh, maybe this here. So now, see, I actually do kind of care about this. I want to know pi command right, and that better be defined as 4. So I'm going to come here and I'm going to do, what was it? Pi underscore command, and then right. No, this is just a packet. Okay, so I want to find its definition. So go to definition. Here is defined as 4. There we go. Awesome. And now there should be 118 here. Let's see. Yes, there is. There is 100, exactly 118. So I can look at now I know I can come in here and I can look at these commands here and I can see exactly what commands I have access to, and I know how to access them, how to send P1, P2 and send it over the TCP. I know all of this within, I don't know how long this video has been going on, but within this time frame. Oh my goodness, this is a game changer, right? Like, this is amazing. Okay. So PyGPIO, Python wrapper. Again, for this right here, I'm not extremely worried about this. Environment variables, local host, yeah, that's fine. Just the IP address and port numbers. Pull downs, daemon return, negative value errors. Okay. Python error handling, C# error handling. So it gives things when we get data back. How do you actually handle errors? Okay, socket exceptions, real world examples. Then it comes here and shows how you're able to actually use the Python to connect to the daemon and do all of that. Awesome. Okay, how you're able to do a PWM signal to control the brightness of, I'm guessing, like an LED or something. So now it shows the C# application, which is of more interest to us because I said that I was that's one of one of the test cases, right? Like I'm trying to test to see how AI helps me to be able to do C sharp. Private. Okay. Client, yep. Right, initialize, and then we're able to just do writes. Yeah, I mean, well, okay, so network communication. This is the TCP socket details. So create a socket, connects, accepts. So this is just the TCP connection protocol. Yeah, okay, that's fine. Characteristics. Each command is independent. Always wait for response to a command. Receive independently. Network by order is little endian on x86 architecture. No packet loss. Order delivery. It's TCP, so we are guaranteed not to lose packets. That's just inherent to the TCP connection. If we were using something like UDP, we would just like accept packet losses. No heartbeat. Connection stays alive. And okay, so heartbeat. I don't know if my Raspberry Pi has a heartbeat LED. Anyways, on electronics, there's usually like an LED which you might be able to see on the device, and when you plug power onto it, it will blink. Okay, and that's just to indicate to you that hey, this device, it's alive, and it shows this, and it gives an indication. Number one, you have power. Number two, you have your program is running, because in the program there's a little loop that just like turns it off and on, and so you know that you're not like frozen or stalled or something like that. So no heartbeat in the context of TCP, that's going to mean that you just keep sending a like message um, to the daemon and say, hey, I'm still alive. I still want to connect with you. Don't drop my connection. But in this case, there's no heartbeat. The connection stays alive until you physically close it. And we saw how to close it in above. Okay, so network security considerations. Warning, the protocol has no authentication or encryption. So anyone can connect if they have access to port 8888 and they're on localhost. There's no password or API keys required. Data is sent in plain text, so we're not encrypting any of the communications between those packets. It's those 16 bytes are those 16 bytes. All right, so recommendation is to run PyGPIOD on localhost to limit to local connections. Use SSH tunneling for remote access. None of this has much interest for me right now, but it's good to know about. Consider adding custom authentication wrappers. Okay. So part 12, debugging and troubleshooting. Check if daemon is running. So this just gives you some like troubleshooting tips. So like check the process, and then try to grep, like you list out all of the processes running, right? And then you search for the PyGPIOD. So make sure that the daemon is running. You can do netstack, grep 8000, okay, and try to connect. Awesome. So test connection from Python. Okay, so you can do that from Python, from C Sharp. Here's a function that you can use to connect to that localhost or that TCP connection. Gives you some common issues that you might run into. So connection refused, permission denied, port 888 already in use. Okay, no such device. slow notifications, architecture summary. Okay, so here is the summary, like architecture summary. And let's see, we are almost at the end. Okay, so architecture summary. Now, again, what I'm doing right now is I actually think that I have gotten to the point where I understand things. But I'm trying to see what AI was capable of, what it output. And now, instead of just trying to do this specific task, I'm trying to look at the meta analysis of what did AI do, how did it do it, and how am I going to do it better next time? Okay. So, my application, so my Python, C Sharp, C, Java, whatever, all of the business logic here. We have the protocol, the binary socket protocols, yep, the daemon layer. This is kind of, because we read through everything, we kind of already understand this. My application, I don't care about Python, I care about C Sharp. Yep, that makes sense to me. Data transformation through the stack. This is kind of, I think, probably because I wrote, where is it? Here, like, but I don't know. Investigate the code, do diagrams explaining everything. I remember I was talking about how data flows. And I think it's probably trying to get this here, but this is actually helpful, like when I am, because obviously you can understand it, but then when you go to actually develop things, you're gonna run into like, okay, well, what exact bits do I need to put in this location, that location? So actually, this is a good like reference when you're developing. So the above was good for getting an understanding. Now this one is a good reference for like, how do you actually like do it? It's a good reference thing to look at, like protocol layer. Okay, network, yeah, daemon layer, yep, hardware layer. Okay. By order, response times, multiple clients, threading. It's thread safe, so it uses mutexes within the daemon. Command flow. So create the TCP connection, get network stream. Yeah, we've already seen this. What makes it work? Runs continuously. Yep. Conclusions and all of the references. And we are done. Okay, so let me come here and let's do a recap. So that was incredible. That saved me so much time and energy to research all of that. I can't, like, I would have been able to come to that point, but it would have taken me a, maybe 1 day, 2 days, 3 days. I don't know how long it would have taken me because there were so many different components within this repository that trying to understand how they fit together. There's a daemon, there is C files, there is Python files. Like these two C files and Python files, they are on top to communicate to the daemon. But then the daemon is also C files. So trying to understand all of those, what is the commands that I'm able to use? Where are the commands actually stored? Is it in the daemon? Is it in the C? Is it all of these things? Trying to understand how they connect and fit together within the greater project would have been very time consuming, and I am extremely impressed at AI's ability to be able to go in, search, organize, analyze, and put the entire project in a cohesive and understandable way such that I am able to go in, look at it extremely quickly, understand each of those components, and now I feel very emboldened, and I think that I am able to move forward with this knowledge extremely confidently, and I am able to, exactly as I said, I am trying to get to the point with AI, is using AI as a tool to become a better engineer, to become a better software engineer, a better developer, to supercharge my development process, make better projects. So not just going online, or not online, but going on my Visual Studio, hooking up to Copilot and saying, build this app, and then letting it do its thing, and I just accept it, right? No. How do I, as a real engineer, use AI to become an amazing engineer? That's what I want to know. And I feel that this exercise right here has really shown me one of the amazing capabilities that AI has, and I am going to absolutely utilize and put this in my tool belt to become a better engineer. So very impressed, very happy that we did this video. I cannot say, like, this is, I cannot say enough. Like, very impressed. And yes. So yeah, thank you guys for watching this video. If you want to see more videos where I am going to be continuing to experiment with AI, now there's multiple things that I'm doing here on my YouTube channel. I do project videos. I do like vibe coding, which what I define by that is I do experiments with AI to try to understand what is its capabilities? How is it operating? How do I increase the capabilities? So the last video that I did was I was exploring MCP, Model Context Protocol. So that allows your agent, like Copilot here, to be able to go out into the world and perform actions. So in the last video, I had it go and talk to my GitHub account, create a repository, push code to that repository, all from my local, and it was able to do actions on my behalf. So that's what I'm trying to do with my AI series, is look at those different capabilities and keep adding tools to my tool set and learn how, as an engineer, can I become more and more competent with AI. So that's what I'm trying to do with my AI series. The other thing is I do, leak coding videos. I do a whole bunch of different stuff. But yeah, so if you would like to subscribe, that would be awesome. I would love to have you along on this journey, and we can continue to try to become supercharged engineers. So thank you for watching. My name is Timothy Lee Grant, and I will see you guys in the next video. All right. Goodbye.